can move them around. But basically, most of this stuff you're going to either have around or you're going to be able to get when you need it. You also, based on your idea, you need some narrative reference points. At least one game that has real similarities to your idea and thoughts about its player narrative. So this is a game where the premise or the mechanics or something is really in line, and where you you've played through the game. You don't need to like the game that is your narrative reference point, but you should have thoughts about what you went through as a player in that game. So second to last is a personal storytelling experience, and this is a little bit touchy-feely, but you really want a time to look back at a time when you felt engaged and empowered as a storyteller. You want to look for your comfort zone as a storyteller and hold on to that because you're going to use that later. For you, this may be telling a story around a campfire, telling a joke or to a laughing audience, or painting a picture. But me, I always think personally about being 10 years old and my first experience with role-playing games. So my friends and I didn't have rule books, but I made up a pretend world, my friends made up characters, and we rolled dice and told collaborative stories it's still this place of warmth and comfort where I feel like anything is possible when I think back at that time. So finally, of course, you need that focus on the central question of game narrative as you go forward and as you get ready to make this thing. You want to keep this about how the premise, rules, and actions come together to create a player's story. You're not testing the mechanics, the look and feel, or the game balance. And you want to keep in mind that those are not what's on the table here. So once you have that all ready, basically my first step is an initial write-up. I lay out the narrative elements of my game. These can be notes. They can be totally informal. They only have to make sense to you. And I'll go through these pieces in the order that I like to use because this is the order that makes sense to me. First of all, the premise. This is going to be the most fun part of this write-up. Just go nuts. Write down everything that's exciting to you about your game. So, you might be like, my game is this world where stories come to life, and there are luck dragons and rock biters and empresses. Write all the stuff that you think is really exciting, but only do this for about 10 minutes, because that'll force you to stick with the things that you think are most exciting and important, and it'll cut you off, because if you don't do this, you could waste a lot of time just writing down exciting things about your game before you get to the meat of it, which is the player. The second thing is putting the player in that world. Think about the player role. Does the player actually assume a role in the game? Are we going to put them in the shoes of a character in the narrative? Are they going to be John Malkovich? How much of an identity are we asking them to take on here? Or are they really just playing the game as themselves? This is the second question you want to answer. The goals of the player. So what's the carrot on the stick? What's pulling them through the experience? So I always go back to Scrooge McDuck, man. Scrooge is so great. Scrooge loves getting money. And you might think that is his goal. It's nice, it's simple, but money itself is not his goal. His goal is to get all this money and then to swim around in a huge pile of his own money. Like most players, his goal is experiential. There's an experience that he wants to get out of this. And your players are going to be the same way. Conflict. So what obstacles are in the way of that goal in your story? What are the barriers to efficient victory? And I say efficient victory because a player can play your game for as long as they are intrigued by it. So Sisyphus here, his goal is to get the rock up the mountain. And his conflict is with gravity. And for some reason, he keeps on playing this game. It's compelling to him. I don't know why. So then we start to get into more of the meat of where narrative comes in. Player choices. Jot down the big interactive choices, and basically this is where you want to look at, in the abstract, big picture, what is the player trying to do? Are these choices tough? Are they meaningful, like deciding whether or not to get on that plane? Are they strategic? Or are they more tactical? Is it more a matter of who to aim at and who to shoot in a moment? These are all choices, and whether they're large or small, you want to write them down. And you also want to write down actions here. So actions and choices, that's a sort of a fine-grained distinction, but think about it in terms of this one-man band. His choices are where to play and when to play, and his actions are his player verbs, his guitar, his cymbals, his drum kit. When he plays those things, those are playing the drums, playing the guitar, those are his verbs. Resources. So this is where you've talked a lot about what the player can do, and this is where you draw the first clear connection between your world and your player. What in the world can the player use? And these resources should be simple to understand if possible, but elegant. In Monopoly is a little bit maligned as a game, but as a resource, Monopoly money is great. It gives an opportunity to the player. It provides information when you look around and see how much money people have compared to how much you have. And it also limits your actions in a challenging way when you don't have the money you need. So for the final element, we're going to go a little farther into the world in the story, and we're going to outline our game events. Now, you don't want to think about this as a formal system of rules, not yet. We still want to keep it high level and think about what sort of changes are taking place. Are these changes regular and predictable? Or are they clockwork, or are they big and dramatic? Put in biblical terms, does it rain twice a week in your world? Or is there a flood on the way that's going to hit at hour 2? These are the things you want to think about. So now that you've done that, you've sort of written down some elements in this area that's formal and informal. You've sort of laid out narrative elements of your game. And you've thought about how the player's going to interact with that world. So now it's time to start building out your story. Doing this well may take you back into your right to make changes, and that's okay. But I want to go through a couple examples of games that do this well, and a couple principles that I think really work. First of all, when you're thinking about story, you want to think about how you're going to show the player your goal. In Journey, you see the mountain with the light, and you don't need to be told to go there. You know. If you can make something like that, fantastic. Give meaning to rules in your game. This is a screen from Dino Run, which is a game where the rules are pretty simple. It's a little running game, and there's a timer where if you fall too far behind, you're going to have to restart. But story was used to really narrativize this goal in a really interesting way. In Dino Run, an asteroid hits, and you have a wall of destruction. This is sort of the extinction level event coming up from behind you. Staying one step ahead of that is much more interesting than a timer. Use characters if you can. Now, people are funny. They see characters everywhere, and once they start seeing characters, they start caring. Use that. Characters can be goals. Keep them safe. Characters can be resources. In classic JRPGs, your options for play are personified as characters. Characters can be conflict. Now, sometimes a character can work as in many narrative elements as once, which is fantastic, like Donkey Kong. He's a source of conflict. I mean, he's holding your goal, this damsel in distress. But he's also throwing obstacles in your path. He's also disappearing back up the level and driving you onwards for a long-term goal. He's such a central part of the game narrative that even though he's not the playable character, he's not playable, the game is named after him. The game is not called Mario, it's called Donkey Kong, because this character is so key to the understanding of the story. Finally, you've got your story events that you've been interested in, the things that happen. Try to tie them into the player's actions as much as possible, the things that you know the player will be doing. And that will make them meaningful. So finally now, you want to cut story points that don't do any of these things, that don't reinforce or showcase goals, call the player to action, give them feedback, or provide a break or reward. I think I don't have as much time as I think I do, so I'm going to go fast. Okay, so next, drafting the rules. Basically, when you're figuring out the rules of the game, now that you've got the elements, now that you've figured out the story, remember, you're playing as the computer, so keep these rules simple. Remember, you're not testing mechanics. So if you can substitute, but you can substitute a challenge for another moment of excitement and test different outcomes. If you can do that, that's great. So dice are a good, simple way to do this. They may not be the same test to a player as combat, but they can provide that little challenging moment. But let's say you really want to test a player's skill to some degree. All right, you can do that. Let's say you think it's important for the game narrative to basically test their accuracy as a shooter will do. So Okay, make a little micro prototype. Put up a dartboard and make that a little part of your game, and success or failure can sort of depend on where they hit on the dartboard. So rules will be different for every game, but there's one more thing I want to emphasize. You may be simplifying actions, but you want to keep the elements of choice strong in your game, or else the player is not going to be doing anything in this narrative prototype. Identify your most important choice points and figure out what's behind either door. So now it's time to actually start building. And I'm going to rush through this because it's pretty straightforward. Choose your pieces and use simple, familiar materials, as I said before. One quick note, don't use anything too light. So you're going to be tempted to draw on paper and just like make a little resource that way. But once you start playing these games, that's going to go all over the place. Weight it down on something like a coin, or it'll scatter. Making the board. So if your final step is setting up a space that's going to abstractly, for the player, represent their world, or more accurately, their screen. This is your game board, and you want it to have weight, you want it to be flexible and sticky, and you want it to have some simplicity and focus to it as well. You really don't want to overcomplicate this with the UI elements that you'll need down the road. Just think about what the player needs in that space. So now we've got a premise, a goal, a board to play on, resources that the players can use to achieve their goals, choices, rules that create conflicts and opportunities, and events that affect and inform play. So I know I started a little bit late, so I'm going to keep on going for a minute or two. You guys can obviously leave if you want. So finalizing your prototype. Basically, what you need to do now that you've created this formal system so it makes sense to you is build out your presentation. And this is where you're using that comfortable place, that storytelling place that really makes you feel like you're conveying a good story. So for some of you, it may be visual or written or some performative, but this is where you're figuring out how to communicate those rules and systems to the player. You're presenting that. Now that you've done that presentation, you're ready finally to start rehearsing the running of this prototype. Phase one, run the prototype on yourself. You want to be able to do one successful solo run if possible, but it has to be possible. You need to do a successful run on your own. And just see this as a conversation between you, the developer who's made this game and knows all the rules, and you, the player, who knows nothing about this game. You're going to find that you missed a lot of things. That's okay. You can just expect perfection, fix those mistakes, run it again. Phase two, once you've gotten a successful run yourself, do a rehearsal with someone who will love you, even if you totally flub the entire thing. You want to leverage their patience to work out the kinks in those presentation elements that you put together. And then once that has worked and you've got that presentation worked out and you've figured out from the first play testers, this person you love, what is really unclear, now it's time to bring in some people whose opinion of this prototype really does matter. Bring back your conspirators, so either the collaborators or people whose opinions you trust. And this is pretty obvious, just listen to this feedback. Oh, am I cut off? Okay. Great. Listen to their feedback and look at what they enjoyed, what's fun, frustrating, boring, or unclear, and adjust that prototype as you prepare for playtesting. God, Deborah did such a good job talking about it was so cool talking about deeper user testing. This stuff is going to be very light. I'm just going to wrap up on this. I used to have a list of questions here. I got rid of it. I will put it up on the GDC Vault. But write down a few questions beforehand because you won't want to think about them afterwards. You want to write down questions, and also, if you can, you want to think about recording the playtests. Use video if possible, but you need to get permission from playtesters. And if you want to improve your presentation style, point the camera at yourself. And if you want to improve your game, you're going to learn a lot more, though, by turning the camera on someone else. So playtesting, I'm just going to sort of roll through that because that's super basic stuff about what it means to playtest. And but the real important thing here is this is not a scientific playtest. It doesn't matter if your variables are all super clean and you're thinking and all your ducks are lined up in the row. This is something that this is a crucible, a trial by fire to make your game better. So you can improvise. If you listen for choices from the player, allow them to skip things that you believe they could skip. And if they have a smart suggestion, if they want to grab the mic and say, hey, this is what I want to do, incorporate it into your play. Just let it happen. And see if it improves the game, as long as it doesn't seem like it's going to mess up the game too much. But whatever you do in those play tests, just note it so that you know, so that you have a sort of log of those changes. So people are polite, so have a third party ask questions for you. And also set aside time to review, again, another really basic thing. So almost done here. So once you've got all that, you've got playtest notes. And you want to look at the biggest problem with your prototype. Is the goal unclear? Is it too hard? Are there dead ends in the gameplay, or is it just not that awesome? This prototype, that's the nice thing about the fact that you made this thing in 3 days. It's disposable. Figure out some bold solutions to your problems. Discard, kill your darlings, and try again. So when you finally achieve something that feels like a narrative outline that is interesting and exciting to players, there's a couple ways you can go. You can expand that prototype. You can generalize, because you're going to learn a lot from having someone run that prototype on you. So that's a matter of getting the rules in sort of a really formal setup so that you can be a player of your game, which will be useful later on. But you can also use this narrative outline. It's sort of this, if your collaborators and everyone all feels like, yeah, this is the game we want to make, this is an extraordinary production tool. You can bust it out into asset lists, think about the animations and all the pieces that you were sort of need to create as part of this game. And then you're also going to see some areas where this narrative, obviously, where the narrative outline, this paper prototype you made, really hasn't, where it's really not addressing issues. So then shift your focus. Maybe it is now time for that digital sandbox. So go back and prototype the next big question in your game. So that's all a lot of stuff. It's a lot of work. Even though it's disposable and quick, it's a lot to do. Why do I go through this process? Why do I think about it this deeply? Basically because a narrative paper prototype is going to help me save time and money. It helps me see if my premise, rules, and choices are compelling, to see if the pieces fit together coherently. It helps me form a shared vision of this whole game with my collaborators as early as possible. It shows me, of course, the player's perspective, but most of all, because it can turn early development, which can be very difficult and unsure, into a fun and empowering experience. Thank you.
美食全支付，购物全支付，缴费全支付，还可以交通全支付。以付之名，新户送50，周年庆比比消费享8%。
Hey everyone, and welcome to this Python and OpenCV course. In this course, we'll be talking about everything you need to know to get started with OpenCV and Python. We're going to start off with the very basics, that is reading in images and video, manipulating those media files with image transformations, and how to draw shapes and put text on those files. Then we're going to move on to the more advanced parts of OpenCV, that is switching between color spaces, bitwise operators, masking, histograms, edge detection, and thresholding. And finally, to sum things up, we'll be talking about face detection and face recognition in OpenCV, so how to detect and find faces in an image, and how to recognize them using inbuilt methods. In the last video, we'll be building a deep computer vision model to classify between the characters in The Simpsons based off some images. All material discussed will be available on my GitHub page, and all relevant links will be put up in the description below. So if that sounds exciting, don't forget to head over and subscribe to my channel, and I'll see you in the course. Hey everybody, and welcome to this Python and OpenCV course. Over the next couple of videos, we're going to be talking about using the OpenCV library to perform all sorts of image and video related processing and manipulations. Now, I won't be delving into what OpenCV really is, but just to be brief, it is a computer vision library that is available in Python, C++, and Java. Now, computer vision is an application of deep learning that primarily focuses on deriving insights from media files, that is, images and video. Now, I'm going to assume that you already have Python installed on your system, and a good way to check this is by going to your terminal and typing python --version. Now, make sure you're running a version of Python of at least 3.7 above. Whatever we do in this course won't really work in some older versions of Python, and especially Python 2. So just make sure that you have the latest version installed. Go ahead to python.org and download the latest version from there. Now, assuming that you've done this, we can proceed to installing the packages that we require in this course. The first one is OpenCV. So go ahead and do a pip install opencv-contrib-python. Now, sometimes you may find people telling you to install just opencv-python. Well, this opencv-python is basically the main package, the main module of OpenCV. opencv-contrib-python includes everything in the main module as well as the contribution modules provided by the community. So this is something I recommend you install, as it includes all of OpenCV's functionality. Now, you may also notice that OpenCV tried to install the NumPy package. Now, NumPy is kind of a scientific computing package in Python that's extensively used in matrix and array manipulations, transformations, reshaping, and things like that. Now, we'll be using NumPy in some of the videos in this course, but don't worry if you've never used them before. It's simple and relatively easy to get started with. Now, the next package I'd like you to install is Sierra. So go ahead and do a pip install Sierra. Now, slight disclaimer, this is a package that I built to basically help you to speed up your workflow. Sierra is basically a set of utility functions that will prove super useful to you in your computer vision journey. It has a ton of super useful, helpful functions that will help speed up your workflow. Now, although we're not going to be using this for a good part of this course, in fact, we'll only begin to use this in the last video of this course when we're building a deep computer vision model, I recommend you install it now so that you don't have to worry about the installation process later on. If you're interested in contributing to this package or just simply want to explore the codebase, I'll leave a link to this GitHub page in the description below. Okay, that's it for this video. In the next video, we'll be talking about how to read images and video in OpenCV. So I'll see you guys in the next video. Hey everybody, and welcome back to another video. In this video, we're going to be talking about how to read images and video in OpenCV. So I have a bunch of images in this photos folder and a couple of videos in this videos folder. In the first half of this video, we'll be talking about how to read in images in OpenCV, and towards the end, we'll be actually talking about how to read in videos. So let's start off by creating a new file and call this read.py. And the first thing we have to do is actually import cv2 as cv. So the way we read in images in OpenCV is by making use of the cv.imread method. Now, this method basically takes in a path to an image and returns that image as a matrix of pixels. Specifically, we're going to be trying to read this image of a cat here. So we're going to say photos/cat.jpg, and we're going to capture this image in a variable called img. Now, you can also provide absolute paths, but since this photos folder is inside my current working directory, I'm going to reference those images relatively. Now, once we've read in our image, we can actually display this image by using the cv.imshow method. Now, this method basically displays the image as a new window. So the two parameters we need to pass into this method is actually the name of the window, in this case it's going to be cat, and the actual matrix of pixels to display, which in this case is img. And before we actually move ahead, I do want to add an additional line, a cv.waitKey0. Now, the cv.waitKey0 is basically a keyboard binding function. It waits for a specific delay or time in milliseconds for a key to be pressed. So if you pass in 0, it basically waits for an infinite amount of time for a keyboard key to be pressed. But don't worry too much about this, it's not really that important for this course, but we will be discussing some parts of it towards the end of this video. So let's actually save this and run by saying python read.py, and the image is displayed in a new window. Cool. Now this was a small image. This was an image of size 640 by 427. Now we're going to try and read in this image of the same cat, but a much larger version, a 2400 by 1600 image. So we're going to say cat underscore large.jpg. Let's save that and run. And as you can see, this image goes way off screen. The reason for this is because the dimensions of this image were far greater than the dimensions of the monitor that I'm currently working on. Now currently, OpenCV does not have an inbuilt way of dealing with images that are far greater than your computer screen. There are ways to mitigate this issue, and we'll be discussing them in the next video when we talk about resizing and rescaling frames and images. But for now, just know that if you have large images, it's possibly going to go off screen.
酥酥脆脆，绵绵滑滑，健达缤纷乐。
So that's it for reading images. We can now move on to reading videos in OpenCV. So let's go reading videos. So what we're going to do is we're actually going to read in this video of a dog. And the way we read in videos is by actually creating a capture variable and setting this equal to cv.video capture. Now this method either takes in integer arguments like 0, 1, 2, 3, etc. or a path to a video file. Now you will provide an integer argument like 0, 1, 2, and 3 if you are using your webcam or a camera that is connected to your computer. In most cases, your webcam would be referenced by using the integer 0, but if you have multiple cameras connected to your computer, you could reference them by using the appropriate argument. For example, 0 would reference your webcam, 1 would reference the first camera that is connected to your computer, 2 would reference the second camera, and so on. But in this video, we'll be actually looking at how to read in already existing videos from a file path. Now specifically, we'll be reading this video of a dog here, and the way we do that is by providing the path. So videos/dog.mp4. Now here's where reading videos is kind of like different from reading images. In the case of reading in videos, we actually use a while loop and read the video frame by frame. So we're going to say while true, and the first thing we want to do inside this loop is say is true and frame is equal to capture.read. Now this capture.read basically reads in this video frame by frame. It returns the frame and a boolean that says whether the frame was successfully read in or not. To display this video, we can actually display an individual frame. So we do this by saying cv.imshow, and we call this video, and we pass in the frame. And finally, for some way to stop the video from playing indefinitely is by saying if cv.wait key 20 and 0xff is equal to odd of d, then we want to break out of this while loop. And once that's done, we can actually release the capture pointer and we can destroy all windows. And we can get rid of this. So basically, just to recap, the capture variable is an instance of this video capture class. Inside of while loop, we grab the video frame by frame by utilizing the capture.read method. We display each frame of the video by using the cv.imshow method. And finally, for some way to break out of this while loop, we say if cv.wait key 20 and 0xff is equal to odd of d, which basically says that if the letter d is pressed, then break out of this loop and stop displaying the video. And finally, we release the capture device and we destroy all the windows since we don't need them anymore. So let's save that and run. And we get a video displayed in a window like this. But once that's done, you will notice that the video suddenly stops and you get this error. Most specifically, a -215 assertion failed error. Now, if you ever get an error like this, -215 assertion failed, this would mean in almost all cases is that OpenCV could not find a media file at that particular location that you specified. Now, the reason why it happened in the video is because the video ran out of frames. OpenCV could not find any more frames after the last frame in this video, so it unexpectedly broke out of the while loop by itself by raising a CV2 error. And now you can get the same error if we comment this out, we uncomment this out, and we specify a wrong path to this image. So let's say CV2 wait key 0, save that and run, and we get the exact same error. This basically again says that OpenCV could not find the image or the video frame at a particular location. Basically, it could not be read in. That's what it's saying. So that's pretty much it for this video. We talked about how to read in images in OpenCV and how to read in videos using the video capture class. In the next video, we'll be talking about how to rescale and resize images and video frames in OpenCV. So see you then.
Calculate the area of a circle. Here is the program code. See the difference we have in this program. Note that for function definition that comes after the main function, remember to add function declaration before the main function. So in this program, here is the function definition. It's after the main function. And hence note that on line 3, we have had the function declaration. On program execution, the user is prompted to enter value for required radius. I enter 10. On line 11, the program invokes function named area. Value of radius and constant value of pi is passed to the function. Area is computed and returned back to main function. Finally, the area of circle with radius 10 is printed onto the output screen.
Hey everyone, and welcome back. In this video, we're going to be talking about how to resize and rescale images and video frames in OpenCV. Now, we usually resize and rescale video files and images to prevent computational strain. Large media files tend to store a lot of information in it, and displaying it takes up a lot of processing needs that your computer needs to assign. So by resizing and rescaling, we're actually trying to get rid of some of that information. Rescaling a video implies modifying its height and width to a particular height and width. Generally, it's always best practice to downscale or change the width and height of your video files to a smaller value than the original dimensions. The reason for this is because, while most cameras, your webcam included, do not support going higher than its maximum capability. So for example, if your camera shoots in 720p, chances are it's not going to be able to shoot in 1080p or higher. So to rescale a video frame or an image, we can create a function called def_rescale_frame, and we can pass in the frame to be resized and a scale value, which by default we're going to set as 0.75. So what I'm going to do next is I'm going to say width is equal to frame.shape of 1 times scale. And I'm going to copy this and do the same thing for the height. Now remember, frame.shape of 1 is basically the width of your frame or your image, and frame.shape of 0 is basically the height of the image. Now, since width and height are integers, I can actually convert these floating point values to an integer by converting it to an int. And what we're going to be doing is we're going to create a variable called dimensions and set this equal to a tuple of width, height. and we can actually return cv.resize the frame, the dimensions, and we can pass in an interpolations of cv.inter_area. Now we'll be talking about cv.resize in an upcoming video, but for now just note that it resizes the frame to a particular dimension. So that's all our function does. It takes in the frame and it scales that frame by a particular scale value, which by default is 0.75. So let's actually try to see this in action. Let's go back to this read.py and grab this code. And we can paste that there. We don't need images for now. I'll comment these out. Now what I'm going to do is, after I read in the frame, I'm going to create a new frame called frame_resized and set this equal to rescale frame of the frame, and let's leave the scale value as 0.75. And we can actually display this video resized by passing in the frame_resized. Resized. So let's save that and run python rescale.py. That was an error. Okay, we don't need this, so let's close that out. Save that and run. And this was our original video, and this is actually a resized video, with the video resized by 0.75 or 75%. We can modify this by changing the scale value to maybe 0.2, so we're rescaling it to 20%. And we get an even smaller video in a new window. So let's close that out. Now you can also apply this on images. So let's uncomment that out, change that to cat.jpg, and we can do a cv.imshow image and pass in the resized image, and we can create a resized image by calling rescale frame, and we can pass in the img. So let's save that and run. And this is our small videos. We're not concerned with that. This is actually the big image, the large image, and this is the resized version of this image. So let's close that out. Now there is another way of rescaling or resizing video frames specifically, and that's by actually using the capture.set method. Now this is specifically for videos and will work for images. So let's go ahead and try to do that. Let's call this def change res. So we're changing the resolution of the image of the video, and we can pass in a width and a height. And what we're going to do is we're going to say capture.set 3, width, and we're going to do the same thing with capture.set 4, height. Now 3 and 4 basically stand for the properties of this capture class. So 3 references the width and 4 references the height. You can also expand this to maybe change the brightness in the image, and I think you can reference that by setting this to 10. But for now, we're going to be interested in the width and the height. Now, I do want to point out this. This method will work for images, videos, and live video. Basically, for everything, you can use this rescale frame method. But the change res function only works for live video. That is video you read in from an external camera or your webcam, for instance. So video that is going on currently. This is not going to work on standalone video files that already exist. It just doesn't work. So if you're trying to change the resolution of live video, then go with this function. If you're trying to change the resolution of an already existing video, then go with this function. So that's pretty much it for this video. So we talked about how to resize and rescale video frames and images in OpenCV. In the next video, we'll be talking about how to draw shapes and write text on an image. So if that's everything, I'll see you guys in the next video. Hey everyone, and welcome back to another video. In this video, we're going to be talking about how to draw and write on images. So go ahead and create a new file and call this draw.py. We're going to import cv2 and cv. We're going to import the numpy package that OpenCV had installed previously, and we're going to import that as np. We will read in an image by saying img is equal to cv.imread, pass in photos/cat.jpg. We can display that image in a new window, and we can do cv.weight key 0. Now there are two ways we can draw on images. By actually drawing on standalone images like this image of a cat here, or we can create a dummy image or a blank image to work with. And the way in which we can create a blank image is by saying blank is equal to np.zeros of shape 500 by 500 and give it a data type of uint8. uint8 is basically an image, the data type of an image. So if you want to try and see this image, see what this image looks like, we can say blank and we can pass in blank. Save that and run. Python draw.py. And this is basically the blank image that you can draw on. So we're going to be using that instead of drawing on this cat image. But feel free to use this cat image if you'd like. So the first thing we're going to do is try to paint the image a certain color. And the way we do this is by saying blank and reference all the pixels and set this equal to 0,255,0. So by painting the entire image green. And we can display this image by saying green and pass in the blank image. Save that and run. Can I broadcast? Yeah. Okay, you need to give it a shape of 3. Basically, we are giving it a shape of height, width, and the number of color channels. So just keep that in mind. Save that. And this is the green image that we get. Cool. We could even change this and try to change this to red. 0,255. Save that. And we get a red image over here. Now, you can also color a certain portion of the image by basically giving it a range of pixels. So we can say 200 to 300, and then from 300 to 400. Save that and run. And you got a red square in this image. The next thing we're going to do is we're going to draw a rectangle. And the way we do this is by using the cv.rectangle method. Now this method takes in an image to draw the rectangle over, which in this case is blank, and it takes in 0.1, 0.2, color, thickness, and a line type if you like. So the 0.1 will specifically be 0,0, which is the origin, and we can go all the way across to 250, 250. Let's give it a color of 0,255,0, which is green. Give it a thickness of, let's say, 2, which is basically the same the thickness of the borders. And once that's done, we can display this image by saying, let's call this rectangle, and pass in the blank image. We can comment this out since we don't need this anymore. And we get a green rectangle that goes all the way from the origin to 250, 250. We can play around with it if you like, so we could go from 250 to maybe 500. And it goes all the way across the image. So you basically divide the image in half. Now there is a way of filling in this image a certain color, and the way we do this is instead of saying thickness is equal to 2, we say thickness is equal to cv.filled. And that basically fills in the rectangle to get this green rectangle. Now alternatively, you can also specify this as -1. -1. And we get the same result. What we could also do is, instead of giving it fixed values like 250 and 500, what we could do is we could say img.shape of 0, of 1 divided by 2, and image.shape of 0 divided by 2. Let's save that and run. Image is not defined. God, this is blank, and this is blank. Save that and run. And we get a nice little rectangle, or square, if you will, in this image. What it basically did is it scaled the rectangle from, instead of being this entire square, this rectangle basically has dimensions half of that of the original image. So moving on, let's try and draw a circle. Draw a circle. This is also fairly straightforward. We do a cv.circle and we pass in the blank image and we give it a center, which are basically the coordinates of the center. For now, let's set this to the midpoint of this image by saying 250, 250. Alternatively, you could also get this. Let's give it a radius of 40 pixels, give it a color of 0,255, which is red, BGR, and give it a thickness of, let's say, 3. We can display this image, say circle is equal to blank. And we get a nice little circle over here that has its center at 250, 250 and a radius of 40 pixels. Again, you could also fill in this image by giving a thickness of -1. And we get a nice little dot here in the middle. Cool. Now there's something else that I forgot, and that is how to draw a line, a standalone line on the image. That again is fairly straightforward. Say draw a line. We use a cv.line method, and this takes in the image to draw the line on and 2 points. Let's just copy these points, basically everything. And this basically draws a point from 0, 0 to half of these image dimensions, so that's 250, 250, and then it draws a line of color 0, 255, 0. Let's set this to full white, to 255, 255, and 255, and basically the thickness you can specify as 3. And we didn't display this image. cv.im show, call this line, draw the line. Blank image. And we get a line that goes all across from 0, 0, 0 to 250, 250. Let's try and play around with this, and let's draw a line from 100 to maybe 250, and then it goes all the way to 300 to 400. Save that, run, and you get a line that goes from 100 to 100 to 300, 400. Cool. And finally, the last thing that we will discuss in this video is how to write text on an image. So that's write text on an image. Now the way we do this is very straightforward. You see, we do a cv.put text, and this will put text on the blank image. We specify what we want to put on. So let's say hello. We can give it an origin, which is basically where do we want to draw the image from. Let's set this to 225 and 225. And we can also specify font face. Now OpenCV comes with inbuilt font faces, and we will be using the cv.font_Hershey_. We'll be using the XXX. You have complex, you have duplex, you have plain, you have script simplex, and a lot of inbuilt fonts. But for now, let's use the triplex. Let's give this a font scale, which is basically how much do you want to scale the font by. Let's set this to 1.0. We don't want to scale the font. Let's give it a color of 0,255,0 and give it a thickness of 2. Let's comment that out, and we can display this image. So you can see I'm show. Let's call this text and pass in the blank image. And we get some text that is placed on the image. You can play around with it and say, hello, my name is Jason. Save that and run. And it goes off screen, like when we're dealing with large images, but there's no way of actually handling this except for maybe changing the margins here a bit. We can do that by saying, let's say 0,225. And it starts from 0 and it says, hello, my name is Jason. So that's it for this video. We talked about how to draw shapes, how to draw lines, rectangles, circles, and how to write text on an image. Now in the next video, we'll be talking about basic functions in OpenCV that you're most likely going to come across whatever project in computer vision you end up doing. So if that's it, I'll see you guys in the next video. Hey everyone, and welcome back to another video. In this video, we're going to be talking about the most basic functions in OpenCV that you're going to come across in whatever computer vision project you end up building. So let's start off with the first function, and that is converting an image to grayscale. So we've written an image and we've displayed that image in a new window. And currently this is a BGR image, a 3-channel blue, green, and red image. Now there are ways in OpenCV to essentially convert those BGR images to grayscale so that you only see the intensity distribution of pixels rather than the color itself. So the way we do that is by saying gray is equal to cv.cvt color. We pass in the image that we want to convert from, which is IMG, and we specify a color code. Now this color code is cv.color_BGR to gray, since we're converting a BGR image to a grayscale image. And we can go ahead and display this image by saying cv.imshow, pass in gray, and pass in the gray image. Save that and run. We do Python basic.py. And this was the original image, and this is the grayscale image. Let's try this with another image. Let's try it with, this image of a park in Boston. Save that, maybe change that to Boston. And this is the BGR image in OpenCV, and this is its corresponding grayscale image. So nothing too fancy, we've just converted from a BGR image to a grayscale image. The next function we're going to discuss is how to blur an image. Now blurring an image essentially removes some of the noise that exists in an image. For example, in an image there may be some extra elements that were there because of bad lighting when the image was taken, or maybe some issues with the camera sensor and so on. And some of the ways we can actually reduce this noise is by applying a slight blur. There are way too many blurring techniques, which we will get into in the advanced part of this course, but for now we're just going to use the Gaussian blur. So what we're going to do is we're going to create a blurred image by saying blur is equal to cv.Gaussian blur. And this image will take in a source image, which is the IMG. It will take in a kernel size, which is actually a 2x2 tuple, which is basically the window size that OpenCV uses to compute the blur on the image. We'll get into this in the advanced part of this course, so don't worry too much about this. Just know that this kernel size has to be an odd number. So let's start off real simple and keep the kernel size to 3x3. And another thing that we have to specify is cv.border_default. So go ahead and try to display this image by saying blur and pass in blur. Now you will be able to notice some of the differences in this image, and that is because of the blur that is applied on it. Right? The people in the background are pretty clear in this image, and over here they're slightly blurred out. To increase the blur in this image, we can essentially increase the kernel size. So from 3x3 to 7x7. Save that and run. And this is the image that is way more blurred than the previous image. So that's it. The next function we're going to discuss is how to create an edge cascade, which is basically trying to find the edges that are present in the image. Now, again, there are many edge cascades that are available, but for this video, we're going to be using the Canny Edge Detector, which is pretty famous in the computer vision world. Essentially, it's a multi-step process that involves a lot of blurring and then involves a lot of gradient computations and stuff like that. So we're going to say Canny is equal to cv.canny. We pass in the image. We pass in two threshold values, which for now I'm going to say 125 and 175. Let's go ahead and try to display this image. Get the Canny edges, and we can pass in Canny. Save that and run. And these were the edges that were found in this image. As you can see that there were hardly any edges found in the sky, but a lot of features in the trees and the buildings, and quite a few, features and edges in the grass and stuff. We can reduce some of these edges by essentially blurring the image. And the way we do that is instead of passing the IMG, we pass in the blur. Save that and run. And as you can see that there were far less edges that were found in the image. And this is a way you can basically reduce the amount of edges that were found by a lot, by applying a lot of blur, or get rid of some of the edges by applying a slight blur. Now, the next function we're going to discuss is how to dilate an image using a specific structuring element. Now, the structuring element that we are going to use is actually these edges, the Canny edges that were found. So we're going to say dilating the image. And the way we do that is by saying dilated is equal to cv.dilate. And this will take in the structuring element, which is basically the Canny edges. And we'll take in a kernel size, which we'll specify as 3x3 for now. And it will also take in iterations of 1. Now, dilation can be applied using several iterations at a time, but for now we're just going to stick with 1. So go ahead and try to display this image by saying cv.imshow, call this dilated, and we can pass in dilated. Save that and run. And if these were our edges, these are the dilated edges. We can maybe increase the kernel size to maybe 7x7 and try to see what that does. Hold on. And nothing much was done. Not much difference was there. Let's try to increase the number of iterations to maybe 3. And it's definitely way thicker, but you're going to see subtle differences with the amount of features and edges that you find. Now, there is a way of eroding this dilated image to get back this structuring element. Now, it's not going to be perfect, but it will work in some cases. So we're going to say, call this eroding, and we call this eroded is equal to cv.erode. It will take in the dilated image, pass in dilated. It will take in a kernel size of, let's start off with 3x3 and give it an iterations of 1, just for now. And we can display this image. And show, call this eroded. And if this was your structuring element and this was your dilated image, this is basically the result you get from eroding this image. Now, it isn't the same as a structuring element, but you can just about make the features there. But you can see that between this and this, there is a subtle change in the edges, in the thickness of these edges. We can maybe try to match these values so that there is an attempt to get back this edge cascade. And yes, we got the edges back. So as you can see that if you compare these two, they look pretty much the same. Yeah, the edges are the same. So essentially, if you follow the same steps, you can, in most cases, get back the same edge cascade. And probably the last function that we're going to discuss is how to resize and crop an image. So we're going to start with resize. So we covered resizing video frames and images in the previous video, in one of the previous videos. But we're just going to touch on the cv.resize function just a bit. So we're going to say resized is equal to cv.resize. This will take in an image to be resized, and it will take in a destination size, which let's set this to 500 by 500. And so this essentially takes in this image of the park and resizes that image to 500 by 500, ignoring the aspect ratio. So we display this image by saying cv.imshow resized and resized. Save that and run. And let's go back to this image. If this is the original image, this is the image that was resized to 500 by 500. Now by default, there is an interpolation that occurs in the background, and that is cv.inter_area. Now this interpolation method is useful if you are shrinking the image to dimensions that are smaller than that of the original dimensions. But in some cases, if you are trying to enlarge the image and scale the image to a much larger dimensions, you would probably use the inter_linear or the inter_cubic. Now, cubic is the slowest among them all, but the resulting image that you get is of a much higher quality than the inter_area or the inter_linear. So let's touch on cropping, and that's basically by utilizing the fact that images are arrays, and we can employ something called array slicing. We can select a portion of the image on the basis of their pixel values. So we can say cropped is equal to the image, and we can select a region from 50 to 200 and from 200 to 400. And we can display this image, call this cropped, pass in cropped. And this is a cropped image of, let's go back here, of this original image. We try to superimpose them. It's probably going to be right over there. Yeah, it's basically this portion. So that's pretty much it for this video. We talked about the most basic functions in OpenCV. We talked about converting an image to grayscale by applying some blur, by creating an edge cascade, by dilating the image, by eroding that dilated image, by resizing an image, and trying to crop an image using array slicing. In the next video, we're going to be talking about image transformations in OpenCV. That's translation, rotation, resizing, flipping, and cropping. So if you have any questions, leave them in the comments below. Otherwise, I'll see you guys in the next video. Hey everyone, and welcome back to this Python and OpenCV course. In this section, we're going to cover basic image transformations. Now these are common techniques that you'll likely apply to images, including translation, rotation, resizing, flipping, and cropping. So let's start off with translation. Translation is basically shifting an image along the X and Y axis. So using translation, you can shift an image up, down, left, right, or with any combination of the above. So to translate an image, we can create a translating function. We're going to call this def translate. And this translation function will take in an image to translate and take in X and Y. X X and Y basically stand for the number of pixels you want to shift along the x-axis and the y-axis respectively. So to translate an image, we need to create a translation matrix. So we're going to call this transmet is equal to mp.float32, and this will take in a list with two lists inside of it. In the first list, we're going to say 1, 0, x and 0, 1, y. And since we're using NumPy, we can import NumPy as NP. And once we've created a translation matrix, we can essentially get the dimensions of the image, saying dimensions, which is a tuple of image.shape of 1, which is the width, and image.shape of 0, which is the height. And we can return cb.warp affine. This will take in the image matrix, so you transmit, and it will take in the dimensions. And with that done, we can essentially translate our image. Now before we do that, I do want to mention that if you have negative values for x, you are essentially translating the image to the left. Negative y values imply shifting it up. Positive x values imply shifting it to the right, and as you guessed, positive y values shifted down. So let's create our first translated image. By setting this equal to translate, we're going to pass in the image, and we're going to shift the image right by 100 pixels and down by 100 pixels. Set to the cb.show, translated, and translate. Tip. Save that and run Python transformations.py. And this is your translated image. It was shifted down by 100 pixels and shifted to the right by 100 pixels. So let's change that. Let's shift the image left by 100 pixels and down by 100 pixels. So we pass in negative values for x. And it moved to the left. Feel free to play around with these values as you see fit. Just know that negative x shifts it to the left, negative y shifts it up, x shifts it to the right, and positive y values shift it down. Moving on, let's talk about rotation. Rotation is exactly what it sounds like, rotating an image by some angle. OpenCV allows you to specify any point, any rotation point that you like to rotate the image around. Usually it's the center, but with OpenCV you can specify any arbitrary point. It could be any corner, it could be 10 pixels to the right, 40 pixels down, and you can shift the image around that point. So to rotate the image, we can create a rotating function. It's called devRotate. This will take an image angle to rotate around and a rotation point, which we're going to set as none. So we're going to grab the height and width of the image by setting this equal to ing.shape of the first two values. And basically, if the rotation point is none, we are going to assume that we want to rotate around the center. So we're going to say rot point is equal to width divided by 2 and height divided by 2. And we can essentially create the rotation matrix like we did with the translation matrix by setting this equal to rotmet is equal to cb.getRotation matrix 2D. We're going to pass in the center, the rotation point, an angle to rotate around, which is angle, and a scale value. Now we're not interested in scaling the image when we rotate it, so we can set this to 1.0. Finally, we can set a dimensions variable equal to the width and then the height. And we can return the rotated image, which is cb.warp affine image rotmet, the destination size, which is dimensions, and That's it. It's all we need for this function. So we can create a rotated image by setting this equal to rotate, and we can rotate the original image by 45 degrees. So let's display this image, call this rotated, and pass in rotated. Save that and run. And this is your rotated image. As you can see, it was rotated counterclockwise by 45 degrees. If somehow you wanted to rotate this image clockwise, just specify negative values for this angle, and it will rotate the image around. Rotated clockwise. Now, you can also rotate a rotated image. That is, take this image and rotate it by 45 degrees further. So let's call this rotated, rotated, rotated is equal to rotate of rotated, and we can rotate this image by another 45 degrees. So we're rotating it clockwise, and we can cv.imshow, call this rotated, rotated, and we can pass in rotated, rotated, lot of rotated. And this is your rotated image. Now the reason why these black lines were included is because if there's no image in it, if there's no part of the image in it, it's going to be black by default. So when you took this image and rotated it by 45 degrees, you essentially rotated the image but introduced these black triangles. Now if you try to rotate this image further by some angle, you are also trying to rotate these black triangles along with it. So that's why you get these kind of a skewed image. So those additional triangles were included over here. But save yourselves the trouble and basically add up these angles and you'll get the final angle. So we can change that to 90 and rotate the original image by negative 90. And this is essentially the image that we were trying to go for. Take this image, rotate it 45 degrees clockwise, and rotate this 45 degrees image by a further 45 degrees. Save yourself the trouble and add those two angle values. So far we've covered two image transformations, translation and rotation. Now we're going to explore how to resize an image. Now this is nothing too different from what we've discussed previously, but let's touch on it just a bit. Resizing, and we can create a resized variable and set this equal to cv.resize. We can pass in the image to resize and a destination size of maybe 500 by 500. And by default, the interpolation is cv.inter_area. You can maybe change this to inter_linear or inter_cubic. Definitely a matter of preference depending on whether you're enlarging or shrinking the image. If you're shrinking the image, you would probably go for inter_area or stick with the default. If you're enlarging the image, you could probably use the inter_linear or the inter_cubic. Cubic is slower, but the resulting image is better. It's of a higher quality. Again, nothing too different from what we discussed before. So we can display this image by saying resize and passing in resized. Save that, run, and we've got a resized image. Next up, we have flipping. How to flip an image. So we don't need to define a function for this. We just need to create a variable and set this equal to cv.flip. This will take in an image and a flip code. Now this flip code could either be 0, 1, or -1. 0 basically implies flipping the image vertically. That is over the x-axis. 1 specifies that you want to flip the image horizontally or over the y-axis. And -1 basically implies flipping the image both vertically as well as horizontally. So let's start off with 0, flipping it vertically. Call this imshow, call this flip, and pass in flip. Save and run. And this is the image that was flipped vertically. Let's try a horizontal flip. And we get a horizontal flip. To really see whether it was a horizontal flip, we can bring these two images together. And if they look like mirror images, then it was flipped horizontally. This is kind of a symmetric image, so it's not that obvious, but bring them together and you can maybe find out the difference. We could also try to flip the image vertically and horizontally by specifying -1 as a flip code, and the image was flipped both vertically as well as horizontally. Mirror images, but reverse mirror images. And the last method is cropping. Now we discussed cropping again, so I'm just going to touch on it. We can create a variable called cropped and set this equal to img and perform some array slicing. So 200 to 400 and 300 to 400. Save that and run. We can display this image. Give it a I'm show. Let's call this cropped, pass in cropped. Save and run. And this is the cropped image. If you're trying to bring this together, not going to be brought together. Can't even grab a hold of this. Okay. So that's pretty much it for this video. We talked about translating an image, rotating that image, resizing an image, flipping an image, and cropping those images. We are basically just covering the basics, the basic image transformations. There are, of course, way more transformations that you could possibly do with OpenCV. But just to keep this course simple and beginner-friendly, I'm only covering the basic transformations. So that's it for this video. In the next video, we're going to be talking about how to identify contours in an image. So if you have any questions, leave them in the comments below. Otherwise, I'll see you guys in the next video. Hey everyone, and welcome back to another video. In this video, we're going to be talking about how to identify contours in OpenCV. Now, contours are basically the boundaries of objects, the line or curve that joins the continuous points along the boundary of an object. Now, from a mathematical point of view, they're not the same as edges. For the most part, you can get away with thinking of contours as edges, but from a mathematical point of view, contours and edges are two different things. Contours are useful tools when you get into shape analysis and object detection and recognition. So in this video, I sort of want to introduce you to the idea of contours and how to identify them in OpenCV. So the first thing I've done is I've written a file, an image file, and I've displayed that image using the cv.imshow method. The next thing I want to do is convert this image to grayscale by saying gray is equal to cv.cvt color img cv.color underscore bgr to gray. And we can display this. So just to know that we're on the same footing, I'm going to run this. So Python contours.py. And we get a gray image over here. Now after this, I want to essentially grab the edges of the image using the canny edge detector. So I'm going to say canny is equal to cv.canny. We're going to pass in the img and we're going to give it two threshold values. So 125 and 175. And we can display this image, calling this canny edges, pass in canny. Let's save that and run. Save it out and save that. Save that and run. And these are the edges that were there in the image. Now, the way we find the contours of this image is by using the find contours method. Now, this method basically returns two things, contours and hierarchies. And essentially, this is equal to cv.find contours. This takes in the edges, so canny, and it takes in a mode in which to find the contours. Now, this is either cv.retter underscore tree if you want all the hierarchical contours, or the retter external if you want only the external contours, or retter list if you want all the contours in the image. The next method we pass in is actually the contour approximation method. For now, we're going to set this to cv.chain_approx_none. So let's just have a top-down look at what this function does. So essentially the cv.findContours method looks at the structuring element or the edges that were found in the image and returns true values. The contours, which is essentially a Python list of all the coordinates of the contours that were found in the image, and hierarchies, which is really out of the scope of this course, but essentially it refers to the hierarchical representation of contours. So for example, if you have a rectangle, and inside the rectangle if you have a square, and inside of that square you have a circle, so this hierarchy is essentially the representation that OpenCV uses to find these contours. This cv.rettlist essentially is a mode in which this findContours method returns and finds the contours. Rettlist essentially returns all the contours it finds in the image. We also have retterExternal that we discussed. retterExternal retrieves only the external contours, so all the ones on the outside, it returns those. retter_tree returns all the hierarchical contours, so all the contours that are in a hierarchical system, that is returned by retter_tree. For now, I'm just going to set this to a list to return all the contours in the image. The next one we have is the contour approximation method. This is basically how we want to approximate the contour. So chain_approx none does nothing, it just returns all of the contours. Some people prefer to use chain_approx simple, which essentially compresses all the contours that are returned into simple ones that make most sense. So for example, if you have a line in an image, if you use chain_approx none, you are essentially going to get all the contours, all the coordinates of the points of that line. Chain_approx simple essentially takes all of those points of that line, compresses it into the two endpoints only. Because that makes the most sense. A line is defined by only two endpoints. We don't want all the points in between. That, in a nutshell, is what this entire function is doing. So since contours is a list, we can essentially find the number of contours that were found by finding the length of this list. So we can print the length of this list. And we can say, up there. And we can say, these many contours found. Okay, so let's save that and run. And we found 2,794 contours in the image. Now this is huge. This is a lot of contours that were found in the image. So let's do a couple of things. Let's try to change this chain_approx simple to chain_approx none and see what that does. See how that affects our length. Now there isn't any difference between those two because I'm guessing that there were no points to compress since there are a lot of edges and points in this image, so there wasn't a lot of compression. So let's change it back to simple. And actually what I want to do is I want to blur this image before I find the edges. So let's do a blur is equal to cv.Gaussian blur. We pass in the gray image and we can give the kernel size of, let's do a lot of blur, so 5 by 5, and maybe we can give it body default of cv.border_default. And we can, if you want to, and we can display this image, call this blur, and pass in blur. And we can find the edges on this blurred image. So let's call this blur. And as you can see, the significant reduction in the number of contours that were found just by blurring the image. So it went all the way from 2,794 to 380. That's close to 7 times just by blurring the image with a kernel size of 555. Okay, Now there is another way of finding the contours, is that instead of using this canny edge detector, we can use another function in OpenCV, and that is threshold. So I'm just gonna comment this out, and down here, what I'm gonna do is I'm gonna say ret thresh is equal to cv.threshold. This will take in the gray image and will take in a threshold value of 125 and a maximum value of 255. Don't worry too much about thresholding for now. Just know that thresholding essentially looks at an image and tries to binarize that image. So if a particular pixel is below 125, if the intensity of that pixel is below 125, it's going to be set to 0 or black. If it is above 125, it is set to white or 255. That's all it does. And in the find contours method, we can essentially pass in the thresh value. So let's save that. Let's close this out and try to run that. Type. Okay, threshold missing a type. Okay, I think I forgot one part. We have to specify a thresholding type. So this is cv.thresh underscore binary. So we're binarizing the image basically. Okay. Let's run that. And there were 839 contours that were found. We can visualize that. Let's print. Let's display this thresh image. Passing in thresh. Save that and run. And this was the thresholded image. Using 125, close this out, using 125 as our threshold value and 255 as our maximum value, we got this thresholded image. And when we try to find the contours on this image, we got 839 contours. Now, don't worry too much about this thresholding business. We'll discuss this in the advanced section of this course more in depth. Just know that thresholding attempts to binarize an image. Take an image and convert it into binary form. That is either 0 or black, or white, or 255. Now, what's cool in OpenCV is that you can actually visualize the contours that were found on the image by essentially drawing over the image. So what I'm going to do real quick is actually import NumPy.
Hey, hello.
NumPy as NP. And after this, I'm going to create a blank variable and set this equal to np.zeros of image.shape of the first two values. Maybe give it a data type of, I don't know, UI into 8. We can display this image as blank. Pass in blank. Just to visualize and have a blank image to work with. Let's save that and go to a blank image. This is of the same dimensions as our original cat's image. So what I'm going to do is I'm going to draw these contours on that blank image so that we know what kind of contours that OpenCV found. So the way we do that is by using the cv.drawContours method. It takes in an image to draw over, so blank. It takes in the contours, which has to be a list, which in this case is just the contours list. It takes in a contour index, which are basically how many contours do you want in the image. Since we want all of them, since we want to draw all of them, we can specify -1. Give it a color. Let's set this to BGR, so let's set this to red, 0,0,255. And we can give it a thickness of maybe 2. And we can display the blank image. So let's call this contours drawn, and we can pass in blank. Save that and run. Okay, there was an error. I think this has to be shape.
美肌的部分，上次我有试过，
So these were the contours that were drawn on the image.
我感觉不出来有什么
Take
差
a
异。
look at the thresholded value. Thresholded image.
对啊，我不知
It's
道是
not
不
the
是我
same
那边
thing.
有设定出
What I
来，
believe it attempted to do
但是它有
is
在
instead
那个
it
OBS
found
里
the
面跑出
edges
来。
of this image, all the edges of this image, and attempted to draw it out on this blank image. let's set this.
有差吗？
So let's set the thickness
GUI 有
to maybe 1,
你说 GUI
so
是
that we
指
have
说
a
它那
crisper
个吧
view.
因为我以为你是写 code 没差异，还是怎样？
就看不出来有没
So
有
these
有没有
were
那个
the contours that were
有没有
drawn
那
in
个
the
特
image.
效的差，有
And
那
in
个美
fact, if
肌
you
的
try
效
to
果
visualize it
因为我
with
看起来好像
Kenny,
一样啊。
let's actually visualize that with Kenny. Uncomment
那
that
程式码
out.
有 run 起来，但是我不知道差异点在哪里，
Those
可
on
能
the
我还要再去实际测那
Okay,
个
that has
真人
an
的影像。
image.
我